So, next example, example 5. So, in example number 5, we need to integrate 2x minus 3 over x minus 1, x minus 2. Okay? So, back to the screenshot. So, is the integral standard? Answer is no. Are we integrating a fraction? Answer is yes. Check f primed over f of x. Okay? Now, in this case, it's not going to be f primed over f of x. So I would say go to the next approach, which is method 4. Method 4 is partial fractions. Okay? So let's try partial fractions here. Let's see whether that works. So back to the paper and pen. So in this case, let's write 2x minus 3 over x minus 1, x minus 2. So remember, this is a proper fraction. So proper fraction means the highest power of x in the numerator is 1. That is less than the highest power of x in the denominator. So when you expand these two brackets, the highest power will be 2 in the denominator. 1 in the numerator is less than 2. We have a proper fraction. That is the reason why we're trying partial fractions. Okay? And also we have a product of two terms in the denominator. That is also why we're using partial fractions. So we're going to write that as a divided by one of the linear terms. So I'll take x minus 1 plus b divided by the remaining term x minus 2. Okay? So let's work out a and b. So remember what I said in the partial fractions integration video. Whatever you have here, in the next step, you multiply your equation by that term. So I have x minus 1, x minus 2. So whatever I have in the denominator here, let's multiply. So by multiplying star by x minus 1, x minus 2. Okay? So if I multiply star by that very term, this is what we're going to have. Left hand side, multiply by that term, you're going to have 2x minus 3. That is equal to a over x minus 1, multiply by that term, that is a into x minus 2, plus b over x minus 2, multiply by that term, that is b into x minus 1. Okay? So let's continue. Now, to calculate one of the constants, so a and b are constants, remember, we need to get rid of one of the terms. Okay, so if I want to get rid of this term involving b, I can choose x equals 1, as 1 minus 1 gives me a 0. Okay, so if I put x is equal to 1, I can get rid of the b term to work out the constant a. Okay, so if I choose x equal to 1, I'll have 2 into x, which is 1, minus 3 on the left. That is equal to a into x is 1 minus 2, plus a b into x is 1 minus 1. We chose x is equal to 1 to eliminate the b constant related term, as 1 minus 1 is 0. So as a result, 2 times 1 is 2, minus 3 is minus 1. That is equal to 1 minus 2 is minus 1, times a is minus a. A therefore is 1. Okay? Let me put a is equal to 1 back into this equation, equation 1. So if I put a is equal to 1 into equation number 1, we're going to have 2x minus 3, that is equal to a is 1 into x minus 2, plus b into x minus 1. Okay? And remember, to work out the remaining constant, so to work out the remaining constant b, you can choose any value of x except the one that you've used. Okay? So don't use the one that you've used, x equals 1, as 1 minus 1 will give you 0, and as a consequence b will be eliminated. So choose any value of x except 1. So if I put x equals 0, say, we're going to have 2 into x which is 0 minus 3. That is equal to x is 0 minus 2 plus b into x is 0 minus 1. Okay? 2 into 0 minus 3 is minus 3 on the left. 0 minus 2 is minus 2. And 0 minus 1 times b is minus b. Okay? So when we rearrange carefully, you might find that the b value is 1. So I found a and b. A is 1, b is 1. So let's replace a and b into equation star. So on the reverse, 2x minus 3 over, and let's remind ourselves, x minus 1, x minus 2, okay? X minus 1, x minus 2, and that is the same as a, remember, is 1, b also is 1, so it's 1 over x minus 1 plus 1 over x minus 2, okay? So 1 over x minus 1 plus 1 over x minus 2, okay? So instead of integrating this, what we had, so instead of integrating that fraction over here, let's integrate these two terms separately. So now let's integrate 1 over x minus 1 with respect to x plus, let's integrate 1 over x minus 2 separately with respect to x. Okay? So let me call these integrals star and double star. So let's integrate them as side calculations. So firstly star, let's integrate 1 over x minus 1 with respect to x. Our integral isn't standard. We are integrating a fraction. Check method 3. Okay, and method 3 in the first screenshot was f primed over f. F of x is x minus 1. F prime when we differentiate is 1. Okay, so our integral is of the form f prime, which is 1, over f of x, which is x minus 1. So the answer to this integral is ln the modulus of f of x, x minus 1. Okay, plus c, just for completeness. And let's do the same with double star. So we're integrating 1 over x minus 2 with respect to x. So back to this flow diagram screenshot. Our integral is not standard. We are integrating a fraction. Check method 3. Method 3, f primed over f. So back to the paper and pen. F of x, let's try that, is x minus 2. Okay. F primed, when we differentiate, we're going to get 1. Okay. And it is working because our fraction is of the form f primed, which is 1, over f of x, which is x minus 2. So the answer for this one is ln modulus x minus 2 add c. So let's use these results in the main calculation. So for the first one, for star, we had ln modulus x minus 1 plus, and for double star, we had ln modulus x minus 2 add c. So this is the solution to that question, example number 5. Example 6, integrate 2x plus 3 over x plus 1. Okay, so back to the screenshot, the flow diagram screenshot. Is the integral standard? Answer is no. Are we integrating a fraction? Answer is yes. Check method 3. Now method 3, the first screenshot, is f primed over f of x. F of x, if we take that as x plus 1, f primed will be 1, so we don't have a related term in the numerator, so that so the derivative of the denominator is not related to the numerator. Okay, so f primed over f of x doesn't work. So back to the flow diagram screenshot. So if method 3 doesn't work, most likely to be method 4, but it isn't method 4 because I don't have a product of 2 or more factors in my denominator. Okay, so it's not going to be method 4. So it's going to be algebraic division for improper fractions. So remember the term improper. The highest power of x in a numerator, so in our example, the highest power of x in the numerator is 1. The highest power of x in the denominator is 1 also. So since the highest power of x in the numerator is greater than or equal to the highest power of x in the denominator, that classes this fraction as improper, and for improper fractions we need to use algebraic division first before we integrate. Okay, back to the paper and pen. So in this case, let's divide 2x plus 3 by x plus 1. So when we algebraically divide, 2x divided by x is 2. 2 times x is 2x. 2 times plus 1 is plus 2. So when we subtract, let's see what we have. So 2x minus 2x will cancel. 3 minus 2 is 1. So the remainder is 1. So therefore, the 2x plus 3 over x plus 1, that is the same as, okay, 2 plus the 1 over x plus 1. Okay, so you can write this fraction in this corresponding form. Okay, so you start with the 2. So it's 2 plus, so you go in this direction, so it's 2 plus the 1 here, the remainder. So the remainder you write here, divided by the x plus 1. So the x plus 1 comes over here. So this fraction is the same as 2 plus the 1 divided by x plus 1. Okay? So as a result, instead of integrating this improper fraction, let's integrate 2 plus the 1 over x plus 1. Okay? So in this case, when we integrate 2, it's 2x plus, and since this is a fraction, let's try f primed over f of x. So when I differentiate f of x, which is x plus 1, we have 1. Our derivative for f primed matches our numerator, so this fraction is of the form f primed over f of x. So the answer is ln modulus of x plus 1 add c. So that is the solution to this example, number 6. So back to the flow diagram screenshot. So is the integral standard? The answer is no. Are we integrating a fraction? The answer is no again. Check method 1. So in the first screenshot, method 1 is substitution. Okay, so let's check substitution first. Okay, so remember the idea. Choose u to be the term containing the power. Okay, back to the paper and pen. So in this case, I could rewrite this integral as, so let's rewrite this as 2 sine 3x into, and cos squared 3x, I'll write that as cos 3x to the power 2. Okay, so our power is 2. The term containing the 2 is cos 3x, so I'll take u to be cos 3x. So du by dx, when I differentiate cos 3x, it's minus 3 sine 3x. Okay, so when I look at the result for du over dx, substitution is working, so the remaining terms that we have in our integral okay, relates to our du over dx, so substitution is working. So let's continue. Du is minus 3 sine 3x dx, okay? And remember, this is where we stop and think. And in this case, if I look in my integral, I have 2 sine 3x with a dx. But over here, we have minus 3 sine 3x dx. So we need to make this match with what we have in our integral. Okay, so we need to get that 2. So first, you can do it in stages. So you can divide by minus 3 first to give you minus 1 over 3 du, that is sine 3x dx upon division. Okay, and then to get the 2, you can multiply by 2 throughout. So if you multiply by 2 on both sides, you'll get minus 2 over 3 du, that is 2 sine 3x dx on the right hand side. Okay, so now we can replace the 2 sine 3x dx by minus 2 over 3 du, and we can replace the cos 3x by u using substitution. Okay, so by substitution, let's rewrite this integral as, so as we discussed, 2 sine 3x dx, that is minus 2 over 3 du. So I'll put the minus 2 over 3 outside the integral sign, keeping the du inside the integral. So these two terms have been replaced, so let's check them. And we're left with cos 3x, that is u to the power 2. Okay, so when we integrate, we're going to have minus 2 over 3. Integration of u squared with respect to u is u cubed over 3. Add c. And when we simplify this, this simplifies to minus 2 over 3 into 3 is 9 u cubed plus c. Okay, so let's write our solution in terms of x. So let's go to the substitution for u. Since u is cos 3x, so let me continue here. That means that we're going to have minus 2 over 9 u, which is cos 3x cubed plus c. So that is your final solution to example 7. So in example 8, we're going to integrate 5 sine 3x e to the power cos 3x. So 5 sine 3x e to the power cos 3x. Let's go to the flow diagram screenshot. So is the integral standard? Answer is no. Are we integrating a fraction? Answer is no. Check method 1. Method 1 that we're going to check is substitution. And remember, there are substitution problems relating to exponential functions. And if an exponential function is involved, I said, in the idea, okay, then take u to be the power. So try your substitution for u to be the power of your exponential. So this is what I'm going to do. So back to the paper and pen. So I'm going to take u to be the power of my exponential function is cos 3x. So du by dx, when I differentiate cos 3x, it's minus 3 sine 3x. So for me, substitution is working. So du over dx is related to my remaining terms in my integral. So it's related to 5 sine 3x. So substitution is working. Du then is minus 3 sine 3x dx. This is where we stop and think. So in my integral, I have 5 sine 3x dx. But currently, I've got minus 3 sine 3x dx. So I need to make these two match. So I need to make this term match our integral. So let's make that minus 3 into a 5. So let's do it in stages. So if I divide both sides by -3 first, I'd have -1/3 du, that is sine 3x dx, upon division of -3. And to get the 5, let's multiply both sides by 5 to get the 5 here. So if I multiply both sides by 5, -5/3 du, that is 5 sine 3x dx. Okay, so by substitution, let's rewrite this integral as, so 5 sine 3x dx, that's going to be replaced by -5/3 du. So I'll put the -5/3 outside the integral. Du always goes within the integral. So let's check these terms. We've replaced them. And we're left with e to the power cos 3x, that's going to be replaced by u. Okay? So when we integrate, it's -5/3. Integration of e to the u with respect to u is e to the u plus c. And let's write our answer in terms of x. So since u is cos 3x, that means we're going to have -5/3 e to the power u, which is cos 3 of x plus c. So this is the final solution to this integral here that we have. Okay.